Well, hello friends. Welcome back to Language Hacking. Today we're going to continue working on the Yuct programming language, and we're going to be implementing some function call stuff. So we already parse function calls, but we don't type check them, and I don't think we can code gen for them either. So we'll just make a simple test program here that we can mess with, and we will, let's see, we're going to call out to a helper function called hello. And hello will do something super cool like print hello friends. All right, so a very, very simple program, but let's see where we're currently at in terms of supporting it. So if we execute the, actually, let me make sure that I have a current version of self-host. So we'll build the self-host compiler, and then we're going to try to run it on calltest.yuct. Okay, so it actually generates code, but if we pipe to Clang format, we should see that this doesn't look entirely well formed. As you can see, there are no parens after here, but if we could get some parentheses in, this particular program might actually work. So let's see what would happen if we would also pass a string to it, for example. Seems like absolutely no difference. Of course, it notices here that we have the wrong number of arguments, but this is not the self-hosted compiler. This is the baseline compiler that generates the IDE errors. Yeah, so there's a whole bunch of stuff that we need to do. I guess we'll start with just making this very, very bare bones program actually work. So I think the issue here is that we are not generating, well, we're not generating parentheses for the call. So let's look at that first, codegen.yuct. Okay, and is there a call expression somewhere in here? Yes, in cogen expression, we call to cogen call, and cogen call, depending on whether you're using, like, these are actually built in to the compiler at the moment because of the variadic parameters. Eventually they're going to be representable in Yuct itself, but right now these string formatting functions actually require some compiler tricks. But for everything else, we go down here, and as you can see, we output the call name, so that would be hello, but there are no parentheses, so we don't actually output any arguments either. So I guess the first thing to do would be to just emit this and say, fix me cogen arguments here. Yeah. Okay, so let's see if that would be enough to get this very simple program to work, at least. I feel like it should, because we're not passing any arguments. Okay, so this looks good on the surface. Let's, double check. Oh, that actually does not work because hello comes after. Right, so in Yuct, we let you put things in any order you want, and then we fix that up in the compiler so that, like, the C++ that we emit actually puts everything in order, in dependency order, or if that's not right, then we emit forward declarations. Here, I'm just gonna take the lazy way out at the moment and not worry about function dependencies and forward declarations. I'll just reorder, and we'll try that one more time. Okay, here we go. So that works. So we have basic function calls with no arguments now works. Very, very simple. Let's commit that and say self-host cogen emit parentheses for non-built-in callees. Yes. And then let's figure out how to actually take an argument here. So let's take a string. And we can maybe even do something like this. Hello. Or why not get fancy and do this? Okay, you don't like this because we are missing the argument label. Sure. In a case like this, I probably would not require the argument label, instead making that argument anonymous. So let's see what happens if we try to generate for this. So what's this gonna look like? Oh, shoot. Oh, we're just getting an error. Oh, interesting. Okay. Variable s not found. So we probably have to implement like parameter variables within the function scope. So let's look at how we'll do that. That's going to be in the type checker. So type checker.yact. Let me actually, or maybe that's too large. Let's see. So variable not found. Okay, presumably this thing right here. So this is in type check expression. So we have a var expression, which is essentially when you're just using an identifier that represents a variable. It's a var expression, and it's supposed to evaluate to whatever the value is of that variable. But we say it's not found because find var in scope fails, presumably. So we don't have a var with the name s in the current scope. Sure. So where are we right now? I think we are in type check function, and then we are sort of type checking the block of the function. That's where we have this print line statement containing the var expression. So if we look at type check function, we'll find a bunch of to-dos here. To do type check return type, resolve concrete types. Where are the parameters? Here are the parameters. Okay, so param vars. Oh, this looks suspicious. To do add var to scope. I feel like we're supposed to add these parameter variables to the scope, but we're not doing that. Why are we not doing that? It's entirely possible that we simply didn't have add var to scope when this code was added. So we can see that now we have it. So I think we should be good to hook that up. So function scope ID, what's the name of the variable? That would be variable dot name, I think. What's the variable ID? Let's see, param vars are checked parameter. It's checked variable. What does that look like? Name, type ID is mutable, and definition span. So we don't have a variable ID here. And the span was variable dot definition span, right? Okay. So I think in order to add the variable to the scope, we have to register it somewhere so that it gets an ID. And I'm sure that we do that by calling somebody like program, or no, current module dot add variable. Yes, that's the one. So we want to add it, and that will give us a var ID. And I can't do this because current module, this is kind of a shortcoming in current version of Yacht, that current module here returns a pointer to the current module, but we get it as an immutable reference, and then we try to call a mutating function on that immutable reference, and that fails. So the current workaround for this, which is kind of goofy, is to just say mute module is current module, and then you can call it on module like that. That's definitely something that we have to fix in the language eventually, because it's just silly. But as I've mentioned before, we kind of are holding off on making any kind of language changes other than like bug fixes and like really, really necessary things, just because we want to focus on finishing the self-hosted compiler so that it can build itself and all that jazz. So we're just gonna live with this type of issue for now. Okay, so that gives us a var ID, registering the variable with the current module, and I wonder if that would be enough. I wonder, cargo. Let's rebuild self-host. And then we'll find out if it can also compile our thing. No, it cannot. Variable s still not found. Okay, so it might be that I wonder if we actually populated checked function params in the first place. So when we type check function pre-declaration, we have params right here. And do we ever overwrite that, I wonder? Like params push or params equal? No, it seems like we don't actually put anything in there. So let's see. Oh, looky here. To do, check parameters. So seems like we have to actually check the parameters and add them to the check function. So here, our job in this function is to take the parsed function from the AST and perform various type checks on it, and then produce a check function object as the output. So we have to type check the parameters and also the return type. And the function type checking is done in two passes at the moment. So we have the pre-decl. I'm not a huge fan of all of these random shortened forms of things, but like the code is evolving rapidly, and over time we'll probably evolve better language use as well. But the purpose of the pre-decl pass, to my understanding at least, maybe somebody else who works on the compiler has a more nuanced understanding, but my understanding is that this is sort of the first pass where we look at parameter types and return types. And then we have a second pass that's just called type check function, and that actually checks the code inside of the function and, you know, type checks all of the statements within that block. And we do that in two passes so that once you are checking code inside functions, then you have seen, you know, the signature of all existing, all reachable functions. So if somebody does a function call, you have enough information to say, oh, this is a valid function call or this is an invalid function call, right? And it's sort of part of how we avoid that ordering issue that I mentioned earlier that we had to work around for now, where in C++ things have to occur in a certain sort of file order, whereas in Yacht and many other modern languages, they do this two-pass solution to allow you to put things in any order you like. Anyway, so we have to type check the parameters. So we presumably we have parameters in the input parsed function. So we'll try something like this. Parameter in parsed function dot params. Okay, that gives us a parsed parameter. And what are we going to do with that? I guess we'll see what it has. It has requires label, span, and variable. So variable, probably the most interesting thing. And there we know if it's mutable, the name, the type, and the span. Okay, so let's see what we are doing in the baseline compiler. Bring up the Rust. Actually, let me split the view here. And we'll see what we do in type check function predecal in the baseline compiler. So what do you do for parameters? These are generic parameters. We're just going to ignore those for now. And here are regular function parameters. So what we do is we call, let's see, we type check the parsed type name. Sure. And then we look at, is the first parameter named this? Then we remember some information about that, and then we create a checked variable object and add that to the checked function params vector. And then we potentially add var to scope if we are told to check scope. Wait, what is check scope? Check scope. If not is generic, then none, otherwise some. Okay, so this is for generic code only, which we are just ignoring right now. Let's get non-generic code working. Yeah, so it sounds like what we need to do here is type check the parsed type. So let's say type is type check type name, parameter variable dot parsed type. And we also needed the scope ID, which here we were passing the function scope ID. So that's probably okay. So that would be checked function scope ID in this case. Okay. Yeah, it's not like, the code gets a little horizontal sometimes, and it's not ideal to have two buffers up like this next to each other. It's fine when you only have the one buffer. And of course, I'm using a bigger text size and a lower resolution than I normally would. Maybe normally it will look like this, but it doesn't come out great in the videos, or it's hard to read for some people. So, but we make do. Okay, so we have the type name, and then we wanted to create a checked variable thing. So we'll call that checked variable. And forgive me while I go and look up what goes in there. This is something that we need to improve the IDE extension to support, like to enumerate all of the arguments here. I wonder, is there a way I can do that actually? Like if I just, no, it doesn't offer completion of that. Okay, anyway, no big deal. So let's see what we put here. So the name is going to be parameter.name. Sure. Wait, you didn't like that? Unknown member of struct parsed parameter name. What was it called then? Oh, variable.name. Okay. Type ID is the type that we just type checked. Is mutable, is parameter. Variable is mutable, and the definition span is parameter. Seems like the completions are not completely right here. Parsed variable definition span. Oh, is it just span? Okay. Okay, so let's see what else do we need. Well, now that we've created the checked variable for the parameter, let's go ahead and add it to the function. So where is it? Right here, checked function. That's the checked function that we are generating in this instance of type check function, predecal. So params push checked variable. Or I guess actually what we really want is a checked parameter. So checked parameter. Okay, and then I have to go and look those up as well. Requires label and variable. Presumably I have that in the parse thing, yeah. And also variable. Okay, so let's call it variable so we can fold that away. Here we go, checked parameter. Okay. Let's see if we've got enough here. Still variable s not found. All right, all right. So, what might we be doing wrong here? Checked function. It's added to the function. Wait, it's added to the module here. Oh, but I wonder, is this a struct? No, it's a class. Okay, yeah, because in Yuct, classes are have reference semantics and are reference counted, and structs have value semantics. So an easy mistake to make is to pass something around that's a struct, and then you modify it somewhere, and then you think that that modification will propagate, but you're actually just passing a value around, and something needs to be a class in order for changes to propagate or be visible elsewhere. Okay, so let's at least see that we are pumping these out. So let's say print line function add param. Okay, and this is the function parsed function name. And we are adding the parameter variable name here. Okay. A little bit of print debugging. Figure out if we're even getting here. Maybe I am totally missing something. Function hello add param s. All right. So we know that we are adding it to the thing. Sure. Then we should probably look at type check function and see how many params we are transferring here in the type check function pass, second pass. Second pass function add how many params exactly? Let's find out. Checked function dot name. Checked function params size. Let's see how many we have, and I guess we can also print out the param. Let's pretty print it. Okay. All right, so we are adding one params, and it's a checked variable named s with type ID 13, which is probably string. And then main has 0 params. Sure. Okay, so variable s not found while we're in this function context. So something has gone wrong here. Like, why is it not showing up in the scope? Add var to scope for the function scope ID. Let's see. The module, let me just check the module is a class. Yes, it is. Add var to scope. Are we doing this right? We see if it exists, otherwise we add it. Okay, so I'm just gonna print line out here. Scope, add var to scope. Name and scope ID, let's say. And then we had not found for the variable. So let's report something in this lookup here, find var in scope. What does that actually do? It gets the scope. Wait, but it doesn't traverse enclosing scopes though. That doesn't seem right. Find var in scope should also look in enclosing scopes. Don't we do that in the baseline compiler? Find var in scope. What does that do? Yeah, it looks like it. So you can see right here that in the baseline compiler, we actually start at the current scope and then traverse the parent scopes as well, looking for a variable with this name. So that's what's missing here. We're not traversing parents. So let's do that. What would be the pattern for doing that? I guess something like mute current scope ID is scope ID. And then while current scope ID or loop current scope ID. Does that actually work? Oh, get scope always succeeds. Oh, I see. So we have to look at the parent, I guess. So here we do this in the scope, and then we say current scope ID is scope dot parent. So if scope dot parent does not have a value, then break. Otherwise, go to the parent. Okay. Because I think what happens here is that we're looking for the parameter s variable in this block scope, but it's actually in this function scope that's sort of a parent of that block scope. I think that's probably what's happening. And yeah, now we actually type check and generate code successfully. So let's see what the code actually looks like. Probably I have to get rid of all of that pretty printing and stuff. So print line, add var to scope. Yeah, I had a bunch of little things here. But this looks like it's an improvement, because we are taking the parameter, we are passing the parameter to outline, which is C++ equivalent of println. But we are missing a parameter, or missing an argument here at the call expression. So we still have stuff to fix, but program is definitely improving. So now we need to look at, we know that CoGen for calls only emits these two parens because we did them earlier, but we now also need to make sure that type check for call actually populates these things. And as you can see here, when we call a built-in, we do populate the args list, but for anything other than built-ins, we don't even populate the args. I wonder though if these could just be passed through here. I'm not actually sure why we treat these differently. I guess because here we don't want to do any other checks than this. We just want to pass them through at the moment until we have variadics. But here we could do stuff like label validation and argument count checks, stuff like that. Once we have overloads, we can do overload checks. But for now, actually, we could kind of just pass stuff through, I guess. What is the worst that could happen? All right. Okay, so, I guess the cogenerator still needs to actually emit the arguments. So let's see. How do we do that? If, or just for, I guess, for arg in call.args.iterator. Eventually, we should be able to say just like this. But for now, since we don't have the right mechanism, we just have to do .iterator to get an iterator. And as you can see, we get a tuple with a string and an expression. So the string is the argument label in this case, which we can just ignore. And we also don't have destructuring assignment support yet. So we have to access the tuple manually by saying like arg.0 or arg.1, but that's going to be okay. So in this case, we want arg.1. So output plus equals type, not type check, cogen expression arg.1. And then we need to also put out a comma until we get to the last argument, or we can also do this. So if first is false, otherwise print or output plus equals comma. I'm just started thinking about Friendly Jordies suddenly, who says something like comma at the end of his videos, but he's saying comment. Anyway, I guess I messed that up. It didn't come out quite right. First should be true when we start, obviously, because it is the first, and then it changes. So let's see how this goes. Looks almost like this should work, I think. Look at that. Awesome. So we have successfully implemented all the necessary things to get this program to run. That is fantastic. Now, we didn't do any diagnostics, and I think I will skip those for now because we already have a bulk of good stuff here. So we'll do that cogen thing first. Just say self-host cogen. Generate argument And function calls. Okay, and then we're gonna do, which one do we start with? I guess we can start by splitting that up into only that. So this was adding variables. What was that surrounding function call? Add var to scope. Yeah, this is a bit annoying, but the git diff tool does not pick up the name of the function that we're in. And I don't even know which software component I would need to fix to get it to recognize Yact functions. But normally I'm used to seeing the name of the function here. So I think maybe that's something that's built into diff itself, that it recognizes C and C++ functions. Anyway, mute module, where did I change this? That was here in type check function. Okay, so when we're type checking functions, we add variables to the function scope for each parameter. Okay. Yeah, so let's, actually these are kind of interdependent changes anyway. So maybe we should just, getting unsure which parts are actually separable. The find bar and scope thing, that's a separate issue. Find bar and scope needs to look in containing scopes. So let's do that thing separately. Make find var in scope, traverse and closing scopes. Okay, and then what did we have at the bottom here? Type check call arguments. Yeah, we can do that. We should add a fix me there though. Type check call. Oops. Fix me. Check argument labels. Fix me check argument count. Yeah, so some fix me's. Maybe they should go here because it's per argument. Anyway. Look at that white space I almost committed. Okay. Self-host type checker. Check call argument for non-built-in callees. We don't, I've left fix me's about labels, argument labels, and counts. Yeah, that needs to be validated as well, but skipping that right now. And then we had just the remaining stuff where we actually type check parameters and add them to the function scope. Check function parameters and add them as variables. And add vars for them. Yes, cool. So that's a decent set of changes. Feel pretty good about that. I wonder if we could even do something cool here, like what if we, instead of doing that, we would get the thing from somebody else like this. Friends. Like that. What if we did that? Would that compile right now? I don't have to rebuild the compiler, but let's see. Name returns friends. Hello name. This all looks good. Wait. I didn't do that right. No, something's wrong. Function name should not return a value. Oh, we don't actually emit the correct return type. See, static void it says here, but it should actually infer the return type in this fat arrow function case. So, okay, let's ignore fat arrows. What if I did this? Would this work? Am I even recompiling? Yes, I am. Okay. Yes, it still doesn't work because we don't actually emit the return type. Wonder if that's easy. Are we just spitting out void for everything? No. Type check. Cogen function. Static. Where is the return type? Qualifier, blah, 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 blah. Wait, it has to be here. If it's main, then this, otherwise static, So Cogen type, return type ID. Oh, we're probably never setting the return type ID for the function. Type check function predecal should probably do something for that. To do, check return type. Well, that makes sense. So let's just slap a quick return type check here. So return type ID is type check, type name, parsed function dot return type. No, what could it be called? Parsed. I have to look in parser. Parsed function has a return type, which is a parsed type, but we need to actually check that. Okay, so we had return type, but we need to also pass return type span. Is that right? Span. Was this not the right thing? Parsed return type span we have. Type check type name takes. Oh, it takes a scope ID. Oh, excuse me. All right, so that would be, what is the current scope ID here? It is checked function scope ID, presumably. Okay, and then let's just say that that is the, we can probably even just do that. It's a little bit sloppy, but let's try it out. Of course, we're sidestepping everything related to generics still in the self-hosted compiler. We'll eventually have to deal with that as well, but it's nice to just get like a little thing at a time up and running. Cogen type else. Okay, so now we're failing to Cogen, I guess what is presumably string. Should be string. So Cogen type else. We are here. Let's print out the type that we're trying to do. So that would be program get type ID. Inference. Oh, wait. Why? Okay, now... Wait, why is that inference? Because we're setting an explicit return type. Unless this actually produces inference. Built-in type string. Let's see what we actually generated here. function has return type. Checked function return type ID. Actually, we need to also say like program get type. So I'm getting a little bit, like it's getting kind of slow to build a self-hosted compiler, which is a bit annoying. We can probably improve that later, but let's see what's going on here. So function name has return type extra. Oh, it's not name that's the problem. It's these other two. They have like inferred return types because it's not specified. So can I just specify that for now and sort of get myself out of this situation? No, that's not allowed, but main is special. So, oh, I guess I didn't need to rebuild the compiler. Okay, yeah, so it works actually if I explicitly specify that this returns void. So let's do that for now and get ourselves off the hook. And we will also remove that debug print. Yeah. So little by little, we are bringing this self-hosted compiler to life. This is, it's a lot of fun for me because I'm so far outside my comfort zone here that I feel like I'm learning new stuff every day. Just by engaging with these types of problems, and it's so much fun. But it makes me tired. Like I sleep really hard lately. Okay, so let's make sure that this actually compiles. It does. It finally compiles and works. Okay, so now we can also do this. Fantastic. And all we had to do was to actually type check the return type. So it was not a big deal. Self-host type checker, check function return types. All right, so I think this is going to be the end of this video here today. So if you made it this far, then I thank you for watching, for hanging out. I hope that you saw something interesting here. I am really happy with how this language is coming along, and the fact that we can slowly but surely build the compiler for the language in the language itself is awesome. I feel like I'm getting better at writing Yect as I go. And obviously we haven't like discovered all of the interesting patterns and coding style and stuff like that, and it's still evolving over time with, I don't know, like I have a growing list of things that irritate me about the language, but I'm just gonna let it stew. And when we get to the point where the self-hosted compiler can build itself, then I'm going to go and actually start working on that list of irritating things. But it definitely feels good enough right now to finish this compiler. So thank you for watching, and I will see you next time. Bye.